We didn't develop any leaks, overload. Hydraulic, the cooling's good. Looking good on the way loop. Covers are all in place. I don't like anything sitting on top of the machine.
Safety glasses on.
I'm running it. Safety glasses are on because we're going to make chips. The whole class has eye protection. We are going to check our program number. Nobody changed it while we were going to lunch. It's 3039. I'm going to go to Memory, Current Commands, Settings, Graphs, and I'm going to hit Cycle Start. And we have a simulation. We have an error. Over travel. If I hit Edit, it goes to the exact place. It's going to a tool change position at the end of the program. This machine is too small to go to an X of 10 inches. I can come over here, change that X to a 5 inches, alter it, reset, Memory, Current Command, Settings, Graph, run it again. I edited the program, altered a setting on a program, I fixed the problem, and now we're ready to run. Everybody cool? Alright. Once again, Memory Current Commands is the display screen that I like to be in. In Display Commands, I've got a portion of my program. I can look right down here, and if I change my rapid, it shows up on the screen that I'm at 5% of rapid. If I make adjustments to my feed and spindle speed, you'll see that they show up on the screen. I can set them back at 100%. I can pull them down. I'm going to run this tape proof at 70% of feed and 70% of spindle. I can see my active spindle speed and feed rate. Obviously it's not running, I have none. I have any active G and M codes, any active tools, offsets, everything that's active is showing to me right here. I have spindle load information. If I'm in a heavy cut, I can be watching to see if I'm going to break an insert. If I'm going to stall the machine, I can watch the percentage load of the axis and spindle. Right up here under coordinates, I have one position for coordinates. If I hit my arrow down key, I can change what I'm seeing right here. Here is my distance to go coordinates. Here is my operator coordinates. Here is my work coordinates, which is from my part program 0. And here is my machine's coordinates. My machine is sitting at home right now. Guys, 5% of rapid, 70% of spindle and feed rate, Memory, Current Commands. I'm going to hit the Cycle Start button, and I'm going to let the machine come down close to the part. Feed hold. I'm going to go ahead and open up the door here. I'm within about an inch of the part in Z, aren't I? If I'm working with diameters, I'm sitting just outside an X of 1 inch diameter, aren't I? Alright, so I'm making that decision. Where am I physically at? And then I'm going to hit my display, or my position display. I'm going to look at my work coordinates. How far am I in front of the part according to my machine? 910 thousandths. I'll buy that. How about y'all? I'm going to look at my X position of 1 inch 200. I said I was just outside the 1 inch diameter. I'm pretty darn close, aren't I? I'm feeling confidence. My confidence level has come up because I physically look at the machine and the control knows where it's at, doesn't it? I'm feeling good about my offsets. I'm feeling pretty good about my program and where it's going to. Alright, so at that point, I'm going to run this dry without coolant just so you can kind of see what's going on. I can go back to my current command screen. I personally like to see my work coordinates up on the screen. I'm just outside my X diameter. I've moved to Z0, where I set Z0 at with my offsets. What's going to happen? See the highlighted line? Where's this machine going to go?
A negative
64 thousandths in X. I'm going to move in X-axis in the negative direction till I reach minus 64 thousandths, which is 64 thousandths on the other side of center line. What kind of process is that? It's a facing operation, right? I'm in a GO1 mode. So I'm in a linear interpolation mode with a feed rate of 6 thousandths per revolution. Okay? If I look up above that, what's that? G96. Constant surface speed is engaged, and I'm asking it to maintain a surface footage of 1600. CAM software, it's very aggressive in aluminum. I'm running 1260 RPMs right now. What you guys need to listen for as this is facing is you're going to hear those RPMs come up, because it's going to adjust the RPMs based on the X-axis location. We didn't do much. Now, what are we going to do? We got a GO1. Our Z is moving in the negative direction about 1.5 inches at 15 thousandths controlled rate of feed. I'm going to start doing my roughing operations in my Z-axis. I'm looking for interference of any bystander tools, inactive tools, breaking a nice chip. Notice my fingers don't get far from this feed hold button during a tape proof, guys. I'd appreciate it if you'd do the same when you're proofing out a program.
Why wouldn't you just use single block, or does this machine not have it?
It does have it. I could put it in single block. It's a CAM software program and a proven post processor that I have confidence in.
Okay.
Here comes a finished pass, guys. I'm running the full profile of the part. It's going to go to X10 with that tool offset active. It didn't error out, so evidently in this particular case got enough room to get to that 10 inches. And remember that 10 inches is a diameter, so it's only physically moving 5 inches from center line. We'll talk about diametral and radial programming real soon. Coming over, I'm going to feed hold that. How far am I in front of that part? 200-300 thousandths? Where am I at on the diameter? I'm underneath my inch diameter. I'm probably somewhere around, I don't know, 700-800. If I go to my position page, I'm at 812 thousandths in X, and I'm 237 thousandths in front of my part. Called that pretty close, didn't we?
Wasn't that on that other page though?
I could have, yes, I could have it on the other page. I like looking at my distance to go as well. Here I can see all of them. These two don't mean a lot to me right now. I don't care how far I am from machine home. And this guy right here is probably set at the machine home. I can change this one to read anything I want it to. Okay? I'm looking at these two, where I'm at from part program 0 and where I'm traveling to. I'm going to move another 3/4 of an inch in Z minus. That's going to put me what looks to be about the center of that middle diameter, and that's where my groove is per print. The print that I showed you up on the big screen. So we're going to cycle start it, let it come over. I can look again at my distance to go. I got another 23 thousandths to go. I got plenty of room. Everything looks like it's going to be kosher and work out well. It'd sound a lot better if I ran coolant on it, but it's a done deal. As we went through all of the steps to write a program, set up a CNC lathe, we proofed out a first run on a program, we ran a simulation, we touched off all our tools, we loaded all of our tools. You've seen the complete process of going from a print to program to machine to finished part. Yes, sir.
On that part right there, we know it's about 1 foot long. It sticks back
The
in
material.
there. The material is.
Yes.
If you needed that part about 3 inches long only, how would you finish that off with it?
I cut it off with that same tool we just grooved with.
Okay.
We just make it a part-off cycle.
Okay.
I wanted to run with the doors open. Parting off a piece of aluminum while it's spinning at a large rate of RPMs tends to make the part want to fly out of the machine. I didn't want to take any of yous out, so I just left it on the end of the stock.
So now you'd measure everything and reset your
Now we'd measure everything to the print, make adjustments to our wear offsets. Remember, we backed off our wear offsets, so by theory, this part should be big. We measure it, find out exactly how big it is, adjust our wear offsets, run it again at 100%, rapid and feed and spindle. Everybody got any questions? Anybody good? Everybody good? Cut!